Thought I'd start out today with just some understanding the instructions that you're going to see in your homework. So students will be able to find the derivative using the chain rule. Homework examples, use the given substitution and the chain rule to find dy dx. So here's the original function right here. And they're saying substitute u in for 2x plus 1. So we're going to put, not this, but we're going to put u into there. So we have y is equal to cosine of u. And then u is 2x plus 1. We're supposed to take the derivative of this using the notation, let's say, of the chain rule. So the outside function is cosine. So if we take dy du, that's negative sine of u. There's the derivative of the outside, and you leave the inside alone. In other words, whatever is in there, we're leaving it. And then du dx, now we're going to take the derivative of the inside, which is just simply 2. Now if you take dy du, multiply times du dx, you get negative 2 sine of u. So those are these two multiplied together. But we didn't start with u. We can't end with u. We made that substitution, but we didn't start with it. So the answer is negative 2 sine of 2x plus 1. And in my opinion, it's making this way more complicated than it needs to be, but it's practicing the notation. And it really gets down to the heart of the chain rule. All right, if you're watching this video at home, I'm going to give them time to do these problems. It says an object, so you might want to fast forward. An object moves along the x-axis so that its position anytime t greater than or equal to 0 is given by, and then here it says find the velocity of the object. So you're going to go v is equal to, with your partner, help each other out. Let's do all three of these. Give it a try. Let's see if you're catching on to this. And there's the last one. So derivative of sine is cosine. Derivative of 3t is 3. So 3 times 3 is 9. So if you wrote it out, 3 pi over 2 cosine of 3t, and then times 3 times the derivative of the inside. So that gives you 9 pi over 2. Any questions on any of these three? Find the derivative of these. All right, I'll help you with the first one. Dy dx is equal to, now the outside function is negative 3, the power of negative 3. So negative 3 sine to the negative 4 of x. There's the derivative of the outside. And then the derivative of the inside is cosine x. So derivative of sine is cosine. So there's the first one. That's the derivative of sine to the negative third. And then plus 2 cosine of x. So that's multiplying down front, reducing the power by 1, times negative sine of x. We can factor out just a cosine. So cosine of x, negative 3 sine to the fourth minus minus 2 sine of x. Oh, that's to the negative 4, not 4. There we go. And I can't, if one power is positive and the other power is negative, you can't factor one out. They'd have to both be positive or both be negative. Any questions on that one? Try the next one. What do you think? What are we thinking? No, it's 1. It'd be, well, let me think. It'd be 1 over sine to the 4th. It'd be cosecant to the 4th. It could be, yes, but we wouldn't bother with that. Yep, not necessary. I wouldn't count it wrong if you did, though. So down, bring the negative 2 down. Sine of x plus x squared to the negative 3. And then multiply by cosine of x plus 2x. Not a whole lot you can do with that one. We start with negative powers, so we can end with negative powers. So I'm not going to worry about moving that to the bottom. Yeah, any questions on that one? Try the next one. See if you remember some. What's the derivative of cosecant? Negative cosecant, cotangent, and derivative of cotangent is negative cosecant squared. That helps you. Hopefully that helps you a little bit. First times derivative of the second plus the second times the derivative of the first. Whew, wow, look at that. It's a mile long. Don't forget the times 2. The derivative of cosecant is negative cosecant cotangent. Derivative of the inside is 2. So the chain rule is happening right there. There's the chain rule. Times 2. Did you forget your times 2s? Probably, maybe. Don't forget those. That's easy to forget. Easy to forget. So negative 2 cosecant to the 3rd of 2x minus cosecant 2x cotangent squared of 2x. Oop, and then the 2 I should probably put out front like that. So we can factor out a negative 2 cosecant 2x. And that leaves cosecant squared 2x. If I'm taking a negative out, that's plus cotangent squared 2x. That's really close to a Pythagorean identity. 1 plus cotangent squared is equal to cosecant squared. So if I minus that over, it'd be cosecant squared minus cotangent squared. But in ours, it's a plus. So this is not, that is not 1. And someone asked last period, does the 2x matter? It would not. As long as they're all the same, it doesn't change the Pythagorean identities. It could be cosecant of 25x. As long as they're all 25x's, it doesn't matter. Questions on this one? That's a doozy. All right, try the next one. I'm going to have to erase this because I didn't leave myself enough room. All right, let's see if I can get this. First, let's see, dy dx. First times derivative of the second. No chain rule necessary. Actually, we could do the chain rule, but the derivative of x is just 1. So really no need to multiply this times 1. So first times derivative of second plus the second times the derivative of the first. That's going to be x over 2 square root of x minus 4 plus the square root of x minus 4. All right, can you look at that and tell me what makes that 0? What makes the numerator 0? Do you think you could tell me that from here? 0 does not make the top 0. 0 plus, well, it makes it imaginary, right? Because 0 minus 4 would be the square root of negative 4. And there's no way. I don't know what makes it 0. And I wouldn't expect any of you to. But that's why we add these two together, so that we can answer that question. Because we'll have to answer that question later. So we're going to practice it now. So we're going to multiply by 2 square root of x minus 4 on the top and the bottom. And we're trying to get common denominator here. So we have x plus 2 times x minus 4 over 2 times square root of x minus 4. Whoops, x minus 4. So this becomes x plus 2x is 3x minus 8 over 2 square root of x minus 4. Now what makes the top 0? 8/3? All right, 8/3 makes the top 0. 4 makes the denominator undefined, or 0, which makes this undefined. So those are the two questions we're going to eventually have to answer. And that's why we add these two together. All right, let's wrap up this slide. Can you try the next two? I know I didn't leave enough room. Just got to find some white space. So derivative cotangent is negative cosecant squared. So negative is a positive. So cosecant squared of 2x squared plus 12. There's the derivative of the outside. So we have a negative times a negative. That's gone. Then times, well, just times 4x, I guess. So the only thing we can really do is maybe put the 4x out front. I would not count it wrong if you didn't do this. You could leave it the way it is, but it's not a right or wrong. It's a convention, how we usually write it. And then this one over here, dy dx, is 7/6, 2x plus 5 minus 6/6. That's to the 1/6 and then times 2. So 7/3, 2x plus 5 to the 1/6. Any questions on those two? All right, this gets in, we're practicing the gateway. Last period I go, here's your gateway, and they're like, oh, really? No, we're practicing the gateway. All right, so try to answer number 1. I've mentioned it, I've said it, I just really haven't said it a whole lot. In order, on the first attempt of this, when we take it, it's scheduled for next Friday, but I told first period that I would be willing to move it up. I don't care when we take it. Let's find the balance of you feeling good about it versus you starting to forget it. So if we wait too long, you're going to start forgetting some of this stuff. If we go too early, you're not ready. So we're going to try to find that balance. I have it set for next Friday. So, and I know you guys are great students. I know you don't want, I think it makes sense to not put it off for too long. We're going to take it. It's not, you can't avoid it. So we'll figure out when we need to take it. We'll see if we can come to a consensus. All right, anyway, on the first attempt, if you get a 28 or better on the first attempt, there's 30 points, 15 questions, 2 apiece. 30 points. If you get 28 or better on the first attempt, I just give you a 30. And the reason I do that is because I don't want someone, if I get a 29 and I'm not allowed to retake it, but someone else got a 15, can retake it and get a 30, I don't think that's fair. But I don't want a bunch of 29s retaking it to get the 30. So on the first attempt, if you get 28 or better, you get a 30. After that, everyone's had an opportunity to retake it. Then you get the 28, the 29, or the 30. So no automatic 30 after the first attempt. Now the good news is you'll have to keep retaking this until you get a quiz score, because I count it as a quiz, of a 28 out of 30. So eventually you will get a good quiz grade, which is kind of a benefit. So that's the motivation. But you will keep retaking it until you get 28 or better out of 30. Any questions? It's just like the gateway last year with the unit circle, except it's derivatives. All right, anyway, with that being said, I have roughly 60-ish, I can't remember exactly, 62, 60, maybe 59, I'd have to add it up again, 59 calc students this year. And some about, I'm going to go with 7 of you will have to retake it because you don't have your limit statement. You miss one other problem, you forget your limit statement, there's your 4th point, you got to retake it again. So don't forget the limit statement on that. Without it, it doesn't make any sense. All right, let's buzz through some of these pretty quick, and then we'll slow down for the harder ones. Number 1 is 54x to the 8th. Not all of these are meant to be difficult. No, some are difficult, some are easy. Number 2, you could make it a lot easier if you make this 5x to the negative 4th. You can do the quotient rule on it. You can get it right doing the quotient rule, but very few get it right doing the quotient rule. So this is negative 20 x to the negative 5th. So negative 20 over x to the 5th. If you leave it as a negative power, I will take a point off. It didn't start with a negative power. It can't end with a negative power. This is 18x to the 5th minus 4. If you don't factor out what you can, I won't give you full credit. Oh, I can't factor out a 4. I can factor out a 2. 9x to the 5th minus 2. Number 4, there's a really hard way to do this one, and there's a really easy way to do this one. I'll show you the easy way. This is x to the 4th times x to the 1/2. When you multiply, you add the powers. So this is really 3x to the 9/2. If you do that little trick, and it's not really much of a trick, it's just rules for exponents. If you do that trick, this is a very simple problem. It's 27/2 x to the 7/2 because you minus 2/2. So we didn't start with, we started with radicals. You got to end it with radicals. So that's square root of x to the 7th. Now what's the hard way? Do the product rule. Don't. But if you do the product rule on that, you can get the same answer, but the percentage is pretty low on who can do the product rule and get the right answer on that. I think if you just add the powers together, it's a pretty simple, pretty straightforward problem. It's a power rule. Questions? Let's go to 5. It's on the next slide for me, but we'll just keep going down the line. 1/2 5x squared minus 4 to the negative 1/2. There's the derivative of the square root part, the outside function, to the 1/2 power, and then times 10x. So that's 5x over square root 5x squared minus 4. So the 1/2 are the derivative of the outside, the 10x is the derivative of the inside. 1/2 of 10 is there's where I get the 5. 6, I got some explaining to do on this one. First, times the derivative of the second. Times 4, derivative of the inside, there's your chain rule. So first times derivative of the second, plus the second, times the derivative of the first, which is negative sine of 4x times 4. So there's the product rule. With the chain rule inside there, you always have to consider the chain rule. This becomes 4 cosine squared of 4x plus, minus, not plus, minus 4 sine squared of 4x. I'll get it. I can factor out, I can just factor out a 4 and that's it. So I know this is a lot of work for 1 point, but so far we have a 1 out of 2. If you leave it like this, you get a 1 out of 2. I want you to finish this, and it's not quite finished. Nobody in first hour could tell me what this is, and I didn't expect anybody to get it. So I'm going to give you guys a chance, and I don't expect any of you to get it either. Does anyone recognize that? If you do, I'll be very impressed. What is it? I'm very impressed. It's not quite cosine of 2x. It's almost. It is in the form of the double angle formula for cosine. So cosine of 2x is cosine squared x minus sine squared x. So you're very close. I'm very impressed that you remembered that. But we don't have x's here. We have 4x's there. So you can plug 4x in for x. So that's 2 times 4x. So it's really, this ends up being cosine of 8x. That's cosine of 8x. So the final answer that will give you full credit is cosine of 8x. You might want to look at this one. The others, there's little tricks to them. I think you want to study the whole thing. I don't think number 2 is going to require a whole lot of studying. The rest of them might a little bit, but definitely number 6 because of this answer right here. I'll expect you to know that, to expect you to be able to do that. And if you can't, come in and we'll go over it and I can help you out. All right, let's keep rolling. This is secant of 5x, tangent of 5x times 5. Like I said, not all of these are meant to be really tough. Don't forget the chain rule on number 7. Let's go back. How far to back do I have to go? Up here. Number 8, we're just testing you on the quotient rule. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I didn't leave a whole lot of room for this. 15 minus 12x plus 8 plus 12x. That's the top. So what, 23 over 5 minus 4x squared. Four times 5 plus 7x to the 5th to the 3rd. So there's the power rule. Multiply by 4, reduce the power by 1, and then multiply by the derivative of the inside. So 35x to the 4th. That's, is it 120? No, 140. 140 x to the 4th, 5 plus 7x to the 5th to the 3rd. Bottom times the derivative of the top. Negative sine of 3x times 3. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And I can take out a negative 5 on top. Negative 5, not an x. This has an x, that one doesn't. So negative 5, that would leave 3 sine of 3x minus cosine of 3x over 25x squared. So negative 3 sine of 3x minus cosine of 3x over 5x squared. OTA, 3rd, 1102. Yeah, I'll just keep rolling with this. First times the derivative of the second. Times 2. So I got the chain rule as well on that. So I'm starting the product rule. First times derivative of the second plus the second times the derivative of the first. All right, what can we take out? We can take out a 3. We can take out a cosecant. And an x to the 3rd. So 3x to the 3rd cosecant of 2x. Yeah. What's left is negative 2x cotangent 2x plus, let's see, 4? Just 4. Yep. Yeah, go ahead.
Why is it negative 2x?
Oh. It would be, I'm taking out of this, I can only take an x to the third out. Doesn't that leave one?
Oh.
Right? Okay. So that left one x, one of the x's there.
You also take a 2 out of that.
Oh, did I miss? Could I take a 6 out? Oh, I think you're right. Oh, yeah, because I have a 2 there. All right, we'll just make it like this. 6x to the third. Thank you. Negative x cotangent 2x plus 2. There we go. So I could have taken a 6 out originally. Not all of them are meant to be super difficult. This one is secant squared of pi over 4x to the fourth. And then when you do the power rule on the derivative of the inside, you get pi x to the third because the 4's will cancel out when you multiply. The derivative of 4 is 0, so we get 12x to the fifth. First times the derivative of the second, plus the second times the derivative of the first. So 12x to the fifth minus 3x sine of 3x plus cosine of 3x. Can't really factor out anything. You can't, I mean, all I did was rearrange it a little bit, cleaned it up a little bit, and that's it. So not much you can do with that one. What causes students to have to retake this is you generally, like that right there, that little 3 will mess you up. If you don't have that 3, I'll give you a 1 out of 2, you know. A lot of 1 out of 2s happen because you make those little mistakes. I do too. I forget chain rule every once in a while. Try not to forget. All right, the last one. Bottom times the derivative of the top times 3x squared. That should be bottom as x to the fourth. Derivative cotangent's negative cosecant squared of x to the third, and then derivative of the inside is 3x squared. So bottom times derivative of the top minus top times the derivative of the bottom. All over the bottom squared. I mean, essentially we're done, right? We're done with the calculus part. Now I got to figure out what I can take out of this. I think all I can take out is x to the third. So can't do a whole lot with this. So there's x to the sixth. So I'm looking at negative 3x to the third cosecant squared minus 4 cotangent of x to the third. I don't know why I've, oh yeah, like that, over x to the eighth. So the final answer is negative 3x to the third cosecant squared of x to the third minus 4 cotangent x to the third over x to the fifth.